2.3 is estimating limit value from graphs. We want to know the difference between the point and the limit. So that's what we're going to do today. So it says if I ask you for f of 6, I'm asking you for the y value at this particular point. So it is a point. So if I were to look at 6, I'm going to the point, which is right here. And that point is, the y value is 4. So the answer would be 4 here. Questions on that?
Miss, what about the open circle?
The open circle is not a point. Is that good? Yes? So we don't go there. That means it doesn't have a point there. Does that make sense? Yeah? Kevin, put your phone in number 4, yeah. So that's the difference between a point and the one that is not a point. An open circle means the point is not there. All right? Now, we want to look at approaching. So this is approaching a certain x value. So we're talking about the function movement, the graph, okay, not the point. So this tells you, let me zoom in so we can see it a little bit better. This reads the limit as x approach 6. And if you see a little negative after 6, that tells you the direction. So this is x approaching 6 from the left side. So if you look at 6, which is right here, right? The left side is right there. This is the left, okay? So I guess we can do it this way. Here's 6, yes? So this is the left of 6, and then this is the right of 6. So what I want to know is, from the left of 6, as x approaches 6 from the left, where's your functions going? That's the movement. So if I'm looking at the left side, here's 6. So the function on the left of 6 is this function right here. You guys see that? So based on that, I can see that the function is moving down toward this y value, which is 3. So my limit as x approaches 6 from the left, the function is moving to 3. That's the function movement versus this is a point. Are we all right? Question. Now, I want to find the limit as x approaches 6 from the right. So that's that little plus means you're moving from the right of 6. What is your function moves to? Well, here is 6 again, right? This is the function next to 6 from the right of 6. You guys see that? So based on that, the function as it's moved closer to the x value of 6, the function go up to 3. So that's what that means. Is that good? Now that you have that, this tells you, right, the limit as x approach 6. Now, if you don't see the minus or the plus, that mean is telling you that they want to know the limit as x approach 6 from both sides. Okay? So this is called a one-sided limit. This is the both-sided limit. This is the left side, this is the right side, this is both sides. So what is the function moving to when x approaches 6 from both sides? Well, from both sides of 6, the function is approaching 3. And notice you can see that it's the same number. So the limit as x approaches 6 from both sides, the function is moving to 3. Questions on that? Are we all right? Okay, let's move on. F at 4. So give me a number for that one. What's f at 4? Remember, you're looking at the point. What is it? 5 is good. So at 4, I don't look at this point because that's an open circle. There's no point there. So you see that? So you got to see if there's another one. And it's right there, right? At 4, the point is 5. The y value is 5. So we want to write that. Now we want to look at the limit, okay? The limit, again, is the function's movement. So it's the curved. I want to find the limit as x approach 4 from the left side. So here's 4. The left is this way. So that means if I'm looking at 4, the curve that's next to 4 is this curve on the left. You guys see that? So where is that function's moving? Well, as x get closer to 4, the function is going down to 2. So that's your movement. How are we doing? Go ahead and find this for me. What is the limit as x approach 4 from the right side? Where's the functions going to? What is that equal to? What is that equal to? So hopefully you can see that here's 4, right? So you want to look at the curve like right next to 4. Is that good? But we want the one from the right. So from the right of 4 is this one right here. So you can see that the curve, right, as x get closer to 4, the function is going up to 5. So this is a 5. How are we doing? So if I were to ask you, well, what is the limit as x approach 4 from both sides? Where is the function going to? Well, here's the problem. From the left, the function go down to 2. From the right, the function go down to 5. They don't go to the same y value. You guys see that? So if I were to find the limit as x approach 4 from both sides, the limit does not exist. It's D and E.
But the one-sided limit would exist.
The one-sided limit exists, just not both sides. Okay? It's like if I told you I want to meet at Istridge. One of you go to Istridge and the other one go to In-N-Out. It's kind of like that. So they don't go to the same location. Yes? So if I told you, well, did you guys meet together? No, we didn't meet because we go to the different location. Is that good? That's the same idea. I want to make sure you change this for me. We don't write equal. Equals mean it's a number. So we have to write this. Change that to is. Okay. All right. Or you have your phone? Yeah, let's put it in. Number 15, I believe. 15. Right? Yeah, 15. Okay. Go ahead and do the next one for me. And see if you can do that one. Go ahead. We're on page 6, yeah, of the notes. All right, let me check in with you. So when you see f at 2 without any limits or the x and then x approach to a number, this asks you for a point. So f at 2, so I'm going to look at 2 right here. We have a problem because at 2, there's no point here. So you guys see that? And from the left of 2, the function is going to keep on decreasing. You guys see that? So we're going to have to write undefined because there's no point there. Is that all right? But when we say the word undefined, we cannot no longer use the equal sign. We good? So we have to cross that out. And then, or you can just write on top of it, you write is. Yeah? Undefined. Because it's not there. There's no point there. Now, we're going to look at the function movement. I want to find the limit as x approach 2 from the left side of the function. So here's 2. From the left, I want to find the curve that's right next to 2 on the left side. Yeah, so it's this one right here. So you don't want to look at these. You want to look at the one right next to that 2. Is that good? So in this case, you can see that from the left of 2, as x approach 2 from the left, the function is going down. And that is negative infinity. Okay? From the limit as x approach 2 from the right, Well, from the right of 2, again, you look at 2. Look at the function right next to 2, the curve right next to 2 from the right. So from the right, you can see that as x approaches 2, the function is going up to 4. So the answer should be 4. Are we all right? Yes? So always look at the curve right next to the number, the x that you want to find the limit for. Okay? Yes?
I thought that if it was an open circle, then it's not a point.
It's not a point because remember, we're not looking for a point. We're looking for the function movement.
Oh.
We're looking for that path. So whether it has a point or not, it doesn't matter. Where is that little line going to? Well, that little line is going up to 4. Is that good? Yes. So that's what, the reason we're going over these is because you're going to see scenario like these where you might have a point and you might not have one. The idea is that when you look at limits, you don't look at points, you look at the little line, okay? The movement of that line. And then based on that, you can see that, well, if the left side of 2, the function go to negative infinity, the right side of 2, the function go to 4, we can see that they don't go to the same location. You guys see that? So they're never going to meet up. And therefore, the limit as x approach 2 from both sides does not exist. Okay, so it's D and E. And so now we're going to have to erase that equal sign, and we're going to write is D and E does not exist. Okay. Now, what is the takeaway? The takeaway is this. When you look at the left-sided limit and the right-sided limit, if the number doesn't agree, the limit from both sides of that number does not exist. That's the idea. Only if they go to the same number, then the limit is that number. If they are different numbers, the limit does not exist. Are we all right? Any question? Okay. Also, one thing to caution. You guys see that this is a negative infinity? That's also mean that the limit does not exist as x approach 2 from the left. Infinity is not one y value. You guys see that? So because we're going to keep going forever. Limit mean you have to stop somewhere. Is that good? There have to be a stop. Okay? So sometimes they might write this, sometimes they might write like do not exist or does not exist. And that's mean the same thing. Any questions on that? Okay. I need you to get a calculator for me, so go grab one. We're going to use the calculator to find the limits. Okay? Go ahead. So what we want to do is we want to go to NumWorks, okay? And then I want to go to the graph. We can't really graph limit. We can graph the function. So we're going to go to graph. Press OK. It's not touch screen, so you got to make sure you use your arrow, okay? And then we're going to have to type this in. So I'm going to go to templates. You can use Y. I tend to use f of x in case I have to evaluate something in the problem. Is that good? So that's always my go-to template. And then I'm going to go write this. Now, to write the fraction, you can just write division right here. And then it's going to pop up the fraction for you. And then that way you can just punch in the value, like -1 on top. And then bring the arrow down. You have a square root. And then the variable is right here where it says cut. So that's your x. So that's there. And then you minus 3. Okay? If the calculator is out of battery, let me know so I can start charging it, yeah? And then just pick something, another calculator. All right, now that I have that, I want to find out what is the limit as x approach 3 from the right side. Do you guys see that? So when I graph, press OK, and then you're going to use your arrow to go up and over to graph, okay? You want that one. And there it is. There you go. Do you guys see that? Now, if I'm looking at this, you guys agree with me, 3 is right here. Now, a lot of students, they have a hard time. They got confused. They're like, well, the function is going to 0. Well, no. I want, as x approach 3 from the right. So from the right, you want to look at the curve that's right next to 3. So I want this end right here. I want this end. I don't want that end. You guys see that? This end is when x go to infinity. Because this end, notice your x is getting bigger and bigger and bigger. Do you guys see that? So if I want to find the limit as x approach 3 from the right, you look at 3 and you look at the curve right next to it. Where is that curve going as it get closer, as x get closer to 3? Do you guys see that? So you want to look at this end, oh crap, and not the other end. Are we all right? So then if I'm looking at this, as x approach 3 from the right, my function is going down to negative infinity. So my answer is negative infinity. Does that make sense? You want to look at this end and not this one. Because this one, look at your x. Your x is getting bigger and bigger. So that's like 7, and then you go to 8, 10, and all that stuff, right? So that means your function is getting closer to 0 when x go to infinity. So keep in mind which end or which piece of the graph you're talking about. Are we good? All right, go ahead and do the next problem for me. See what it is. What you want to do is you want to go up right here and then go back to expression. Okay, you can clear that and then press OK to add the element again. Go to template. All right, go ahead and do that for me. When you type, if you have like the square root of x plus 1 and you want a minus 2, if you continue to type, it's going to stay inside the square root. You don't want to do that. Use your arrow to go out first. Oh, not that much out. Like this, like that, okay? So go out, and then you minus 2. Then the 2 will stay outside. So use your arrow, just go 1 tap. I went 2, so that's way too much. Then, boom. This is x minus 3. Now, let me ask you this. Where do I want to find the limit here? From both sides of 3, because there's no sign. So this is x approach 3 from both sides. So you're going to look at 3, and you're going to look at the left of 3. Where does it go? And the right of 3. Where does it go? Okay? Good. Go ahead and do that. Oh, I like that. They have the little open circle there. Oh, nice. That's cool.
Is undefined and does not exist. Is that the same thing? Or?
Yeah, very similar. But does not exist, we look at limits. Undefined, we look at particular points. So is the name is specific for certain things. Yes. So if I'm looking at this one right here, I think we can use the little, the trace, right? These arrow right here to see where we're going for that one. You guys see that? Now, at 3, if you ask me, like, Ms. Ram, why do they choose this number? Well, because if you plug in 3 right here, this is when the function is undefined. You guys see that? 3 minus 3 is 0. Your denominator cannot be 0. So that's when your function is undefined. And so if the function is undefined, we still want to know what's the function movement around there. Do you guys see that? The point is not there, but what about the function? Where is it? How does it behave around that point? Okay, so then based on this, I can see that, what is it? I'm going up very close to 2.24, right? And what about on the left side? So here's the left. I'm going there. So that is very close to 0.25. Do you guys see that? So that's 0.257, and then the other one is like 0.24. You guys see that? Now, when the trace options is very limited because it doesn't give us it doesn't let us go any closer than that. So this is another way that you can do it. You guys see this number right here? Oh, no. Hold on. Go back. Okay, you see this number right here? It says 3.48. Yeah? It's not very close to 3, isn't it? Okay, so what we can do is we can type in the x value and see what the y value is. So this is what you do. You don't have to do anything except you punch in the number. So if I were to look at from the right of 3, then I can choose the point very close to it, like 3.01. You guys good? Press OK. Now look at your numbers right there. That's pretty close to 3 there. You have a y value is 0.2498. You guys see that? Now I can go closer by adding another 0 before that 1. So I